today we have the opportunity to discuss a little bit what the future will look like, especially for the cars of the future. And for that, I would like to hand over the stage to Manuel Alves for a keynote title, Behind the Intelligent Car.
Hi. Thank you. So, well, we are in Stuttgart, right? So we have to talk about automotive a little bit. I'm going to walk you through a very short presentation to kind of feed the discussion for the dinner tonight, hopefully, talking about how we can together build a foundation that is made of partners, ecosystem partners, building components to help us build a reliable foundation to enable not only intelligent cars, but intelligent mobility, including robots in the future. So I will talk about robots. The way we see the technology trends evolving at NXP is going from a world that used to be analog, became on demand, and now that anticipates and automates everything we do. When you think about the most complex robot you can build, we think of the car as the ultimate robot. Ultimate because it is operating at the edge on a battery, has to be functionally safe, has to run more and more AI ML workloads in a real-time fashion, in a deterministic fashion, and that with the maximum security in order to prevent from any kind of attack, cybersecurity, anything. So when you put these things together and think about what is the most complex system that requires all these things, well, a car is pretty much close to it. And we add this word in parentheses, responsible, because we believe that in order to be safe and reliable and everything, we have to trust the platform. We have to trust not only the hardware, but the software that you build this system around. So that's what the word responsible means. There has been a lot of talk everywhere for many years around building software-defined cars. And now, a few months ago, or maybe a year ago already, we heard the term AI-defined cars or vehicle. And frankly, we struggled with that notion initially. We're like, what does that mean? Do you define a car by how it's built or what software runs on it? No, we define a car by what it does. And so at NXP, we prefer to talk about the intelligent car, meaning a car that anticipates and automates. There is a good example of that, by the way, in the demo room there, a startup that is showing a door handle that kind of anticipates you coming close to the car by showing you what the handle is and how to open the car. That's a great example of what I mean by that. So the cars have evolved to become more software-driven, and now with AI at the edge, they become more intelligent. So what does that mean to be intelligent as a car? We have a few examples here on the right side that are real-life examples. Those are things being developed today with industry partners and startups in order to make that car be more data-driven. So you need some kind of intelligence data orchestrator in the central processing piece that will ensure that your data is kind of clean, labeled, timestamped, and everything to build a reliable system that can operate in a deterministic manner. We see AI being used in imaging radar. So it is not just used in vision. When you think about ADAS systems, it is also being used now in radar, taking a point cloud from the radar front-end sensing equipment, and with that point cloud, finding the objects and the clear path for driving. A classical case that was one of the first use cases was predictive maintenance, as your car, especially with electric cars now, need less and less maintenance. You don't have to go to the workshop or for service anymore to change the oil that often. Then it poses a problem for the tear and wear and maintenance, and how do you anticipate anything that could break. So looking at all the sensors available in the car, you can actually predict and see a lot of what's happening and what could happen in terms of predictive maintenance. On that topic of sensing, we can also build virtual sensors. Virtual sensors mean you take existing equipment, existing sensors, and you can either replace some of them because they are redundant, because you can kind of extrapolate or analyze data coming from other sensors to replace that function, or create new kind of sensors. Typical example of this is a road condition sensor that doesn't exist. But if you look at the suspension, by the behaviors, you look at the gyroscope from the airbag system, the vibrations, you look at the vehicle speed, GPS data, you can combine many things and you can actually determine the road condition without using any extra sensor. That's an example of that, and that's something, models already exist to do that. And finally, in audio, very easy to understand, like noise cancellation, of course, but also things like siren detection. So you think about listening to your favorite music, very loud after work, and you're in a congested road, and you don't hear the ambulance coming from the back because you're listening to music. Well, that's a very practical example of how that can help cars getting out of the way for the ambulance to move. So all these examples are real, implemented today on our products, and they are going to hit productions in the years to come. In order to do that in a safe and secure manner, you need a software, hardware foundation. So 1 year ago, we announced our CoreRide platform. What you see on the left side is a classic. You build hardware, you put software on top, and you have a stack, okay? Everybody can do that. What we decided to do is think of it as a chipset level. So in the middle, you see a picture that illustrates a processor in the middle, some peripheric ICs, and we're putting some software around this as a glue to make it work together in an optimal fashion with guaranteed system-level KPIs to guarantee, for instance, boot-up times, wake-up times, latencies on the bus, with the intent to be deterministic, to be a trusted foundation for software-defined vehicles. And what's happening next is the picture on the right, is that now we have this foundation, it's available now. How can you connect these different elements of the car in a bigger system that can exchange data, that is available from the different sensors around the car to become more intelligent? So that's where we're going as a company in automotive. Okay, I'll skip the promotional part on the product part numbers. I will go straight to the how to make it more concrete. So we have, this is how the car looks like, to engineers at least. You have some central processing, some zonal processing around the edges. And so to make it concrete, we launched a new product earlier this year at CES that is called the S32N7, that is meant to be that exact central compute that is there for safe and reliable operations for the core vehicle functions running edge AI. So we have a neural processing unit integrated in that processor, especially to do what I just said earlier around the data intelligence and data management around the car. We didn't only do a product, we did a reference system, as we call it, to demonstrate that capability. And with the acquisition of a startup called Aviva Links, I'm mixing up, Kinara. The Kinara startup we acquired with their AI IP, that's the small board you see on the left side. We can extend the AI capability of our products by adding something like 40 to 100 ETOPS on top of capability that works seamlessly through a PCIe interface with our N7 processor that is available today. On top of that, for zonal applications, so the things you saw around the car in the corners, we have created a reference system, we call it, because reference design is kind of undercoding the capability. Reference system means we are validating system-level KPIs on this hardware with our software platform, our CoreRide platform, working with partners on the networking side, with AI stacks. We have an AI toolchain that we call EIQ, that is the same across the entire company for NXP. And with that, you can deploy AI, not just in central compute, but also at the edge of the car, so very close to where the actuators are, the sensors are. So that's our play in physical AI in automotive through this kind of like staged enablement. Now, let's look a little bit beyond the vehicle. That was the title of the presentation, beyond the intelligent vehicle. When you look at the robots world, which we heard a lot about today, you have a continuum of complexity. From a simple, I would say rather simple factory arm robot to the humanoid being the kind of the most complex robot you can build. And what you can see is that all these systems kind of have a lot in common. They have multiple ECUs, they have to communicate with each other wirelessly over some wires. You have some kind of central master device, you have some remote nodes, actuation in one place, sensing in another place. Well, that concept of the CoreRide platform and that concept of system enablement for AI at the edge actually very well applies to the robotics world. So at NXP, we think platform across all the edge devices. We want to think about our portfolio as being a foundation for this platforming to happen with an ecosystem of partners that can also provide solutions that scale across our microcontrollers that you can find on the left, the MCX, the S32K families for automotive, up to the apps processors and the ARA NPUs on the right, complemented with our connectivity portfolio, our sensing portfolio, networking devices, power and energy, meaning the PMICs around it. So we want to build that kind of reference platform for the edge that is very scalable. So when you think about NXP, think about us trying to bring intelligence at the edge with an ecosystem, with a platform. And in closing, I would say the edge is our home. Thank you.